Welcome to this explainer. Okay, so if you're gearing up for the Microsoft Azure AI 901 exam, you're probably feeling, well, a little overwhelmed by the sheer volume of concepts. I totally get it. But here's the thing. Passing this exam isn't just about rote memorization. It's really about adopting a completely different way of thinking. Today, we're going to put on our detective hats and decode the actual logic of the AI 901 exam. We're going to learn exactly how to spot the hidden clues in every single scenario. We're going to stop thinking like everyday users and start thinking like AI architects.
Listen to this rule because it's absolutely crucial. AI 901 scenario questions usually test the first correct match between requirement, Microsoft Foundry capability, model or service boundary, and observable validation evidence. Understanding this specific chronological sequence is literally the secret sauce to dominating this exam. It completely separates a passing score from a failing one. If you jump ahead to a later step before proving the very first one, boom, you've fallen into a trap.
So here is our syllabus for today. First, responsible AI traps. Second, model selection order. Third, mapping AI workloads. And finally, your exam action plan. Let's dive right into Section 1, Responsible AI Traps. Fixing the root, not the symptom. Okay, this brings us to a massive concept, the operational dependency. On this exam, the policy lens is your core priority. The test prioritizes safety, fairness, and accountability way over sheer performance. So, a blocking dependency in a scenario is almost always the verifiable governance evidence attached to the user workflow. It's not about throwing a bigger model at the problem or making some broad network change. The first dependency is always a verifiable, responsible AI control. Honestly, if your app hides its limitations or collects unnecessary data, it is failing the exam scenario even if the code runs perfectly. Let's look at a crime scene. Actually, scratch that. Let's look at a practice question. Read this scenario with me. A support assistant gives confident policy answers, but users are not told responses may be incomplete and no team owns review of harmful outputs. What should be addressed first? Think about that operational dependency we just talked about. What is the glaring missing governance here? If you approach this like a traditional IT admin, you're going to fall right into a trap. It's super tempting to say, hey, let's increase model deployment capacity, or let's lock the assistant down in a private virtual network. But tuning capacity or locking down networks absolutely fails to fix the root problem. The real symptom here is user overtrust and a total lack of safety oversight. The correct dependency is fixing the governance first. You have to add transparency wording and define a clearly accountable review path. And this is why it's like a giant puzzle, right? High-level principles translate perfectly into verifiable inspection points. If you skip an impact assessment, well, your review simply cannot prove that harm was mitigated. Without a grounding disclosure, users are going to overtrust the generative output. Missing a data collection boundary? That means you're collecting unnecessary personal data in your logs. And without an accountability owner, unsafe output literally has no one to fix it. If any of those failure states exist, your app isn't ready, period. So, consider this your mental cheat sheet. When you're reading a question stem and you see any of these specific words: fairness, transparency, privacy, responsible use, review, disclosure, sensitive data, or accountability, ding, 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 alarm bells should be ringing in your head. Seeing these exact cues means the correct answer must name a responsible AI control. Moving right along to Section 2, selecting the right model, capability before parameters. You've got to follow this strict 4-step execution path. Step 1, classify the task by its input and output modality. Step 2, select a model that actually has the required capability. Only then, at Step 3, do you start messing with deterministic or creative parameters like temperature. And finally, Step 4, run a test invocation. Input modality and capability absolutely have to be proven before any parameter tuning happens. I mean, think about it, you cannot tune a model that fundamentally cannot consume the input you're giving it. Let's test that logic out. Imagine a developer needs an app to answer questions about an uploaded product image and a text prompt. Which selection criterion matters first? Think back to that execution path we just laid out. Look really closely at the input modalities mentioned in the prompt. I know, the distractors on the exam look incredibly tempting. You might think, oh, let's drop the temperature for accurate answers, or let's grab an embedding model, but no way. Tuning randomness fails entirely if the model can't even process the visual input. And an embedding model, that supports similarity search, not image interpretation. You must prove capability first by choosing a deployed multimodal model that natively accepts both image and text input. That's your first priority. Because look at what happens. Picking the wrong attribute completely breaks your technical dependency chain. If you get the capability family wrong, the client literally cannot call the required action. Misjudge the context window token budget, your requests truncate or fail before the required evidence is even included. If you mess up the temperature on a strict data extraction task, you're going to get wildly inconsistent answers. And of course, without the right endpoint credential, you just get an access denied response. It's capability first, identity second, parameters third. To lock in this model selection mindset, memorize these crucial exam cues. When you see terms like uploaded images, context size, temperature, deployment name, endpoint, or unsupported input, you need to shift immediately into model capability and deployment parameter reasoning. These words are pointing you directly toward verifying that dependency chain we just talked about. All right, Section 3, Mapping AI Workload Patterns, Defining the Output Contract. Here's the deal. When you encounter a workload recognition question, you are really just looking at an output contract question in disguise. The ultimate, non-negotiable deciding factor is the exact evidence shape the application demands. The correct exam option is always the one that unlocks the blocked workflow by delivering data in that precise format. Let's put this into practice with a real-world scenario. A claims processing app must read uploaded repair invoices and return vendor name, invoice date, line items, and totals. So, which workload pattern is the best match here? Try to identify the highly specific data shape required by this application. What exactly does it need to return to function? The big trap here is falling for what we call adjacent workloads. These are services that deal with similar data, sure, but they transform it into completely the wrong shape. Distractors like sentiment analysis, text-to-speech, or image generation are just completely wrong directions for this task. The correct dependency is information extraction with content understanding, because that specifically pulls out the structured fields, the names, the dates, the totals, that your app contract actually demands. You should always be asking, what must the app return first? If you need specific labels but use text analytics, well, your app just receives paragraphs of prose. If you use a vision generation model when you actually need image understanding, it generates brand new images instead of analyzing the one you have. And if you need structured fields but you don't use information extraction, your output completely lacks the required schema. You have got to match the output evidence to the right workload family. When you're diagnosing these workload questions on the test, these powerful verbs are absolute dead giveaways. Keep a close eye out for them. Transcribe, synthesize, detect, generate, summarize, classify, extract. If the prompt explicitly says extract, you know for sure you are looking for an information extraction workload, not a generation one. Just match the verb to the output contract. And finally, Section 4, your exam action plan, putting the detective mindset to work. Here is your test day game plan. This is the exact chronological diagnostic framework you need to execute. Step 1, read the stem specifically hunting for the input modality and the required output contract. Step 2, find the operational dependency. Ask yourself, what is actually blocking the workflow here? Step 3, identify the very first proof point needed, whether that's a capability match or a governance control. And Step 4, ruthlessly reject symptom fixes that try to tune parameters before proving the foundational capability or safety. I'll leave you with this final provocative thought to cement your new mindset. If your perfectly accurate AI model collects unnecessary personal data and lacks a named review owner, is it really ready for production? The answer, as you now know, is absolutely not. Governance and capability always come first. Keep applying this structured detective mindset and you are going to absolutely dominate the AI 901 exam. Thanks for joining me on this explainer and happy studying.